All right, let's dive in. Today, we are cracking open the architectural plans for a really fascinating local AI called MindShard Agent. We're going to take a tour of its blueprint to see exactly how it's built, how it thinks, and what makes it both incredibly powerful and, more importantly, safe.
So what is this thing really? Well, at its core, MindShard Agent is a desktop chatbot built with Python. But the key word here is local. This whole thing runs entirely on your machine. It uses AI models through a system called a llama, which means you have total control and, actual privacy.
Okay, so you have this powerful AI living right on your own computer. That's cool, but it also brings up some pretty big questions, right? Like, how does it actually organize its thoughts? And how does it interact with your files without, causing total chaos? To get those answers, we've got to look at its core design. First up, let's talk about the brain of this operation. What's super interesting here is that it's not just one big single brain. It's more like a whole committee of specialized minds all working together. It actually uses 7 of them. 7? Now you might be thinking, hold on, why on earth would one little chatbot need 7 different AI models to work? It might seem like overkill, but it's actually a really clever strategy. And here's where that divide and conquer approach really shines. See, instead of one giant model trying to do everything poorly, MindShard Agent gives each model a specific job. You've got one for your primary chat, another for planning out tasks, a dedicated one for coding, and even one just for understanding documents. There's even a tiny super fast model that does quick checks, like figuring out what you're trying to do. This whole setup just makes it way more efficient and a lot more accurate. Now, a smart brain is great, but it's pretty useless without a good memory, right? So let's move to the next part of the blueprint and see how this agent remembers things, because it is definitely not just one simple log file. The agent has this really smart 2-tiered memory system. So you've got the STM sliding window. Think of this as its short-term memory. It keeps the last 10 turns of your conversation right there, front and center. That's the immediate story. Everything else gets filed away into what's called the evidence bag, and that acts as its long-term memory. And there's this quote from the design docs that just nails it. The window is the story, the bag is the footnotes. It's perfect. The sliding window gives you the flow of the conversation, the story as it's happening. The evidence bag holds all the nitty-gritty details from the past, the footnotes. So the agent can always go back and reference those notes whenever it needs to without getting its main working memory all cluttered up. So here's how it actually uses that long-term memory, and this is the really clever part. It has a process called 2-pass retrieval. First, the model gives an initial response, its best guess. Then some internal checks kick in to see if it seems uncertain. If it thinks it might be missing some context, it literally pauses, digs back into the evidence bag for more details, and then completely regenerates its answer with that new, richer information. It's like the AI is double-checking its notes before giving you a final answer. Okay, so we've got a smart agent with a sophisticated memory. Awesome. Now, what can it actually do? This is where we look at the agent's workshop, the tools it has in its belts, and, crucially, all the safety rules that keep it in check. And wow, its toolkit is seriously impressive. It can run command line instructions, safely in a sandbox, of course. It can write and read files. It can even run Python scripts. These are incredibly powerful tools that let it do real, actual work on your system. But of course, when you give an AI those kinds of tools, you'd better have some serious guardrails in place. And this thing is locked down tight. We're talking about 6 distinct layers of security. A command policy makes sure only safe commands get through. A path guard guarantees it can never, ever leave its designated folder. There's a block list for risky file types, limits on file sizes, and it even has to ask you for permission before doing anything destructive. This is power, but it's power that is very carefully contained. We've seen the blueprint for today, but what about tomorrow? Well, the roadmap shows a really clear priority. Before they start adding a bunch of new features, the developers are focused on cleaning up and refining the architecture that's already there. And you have to love the honesty in this quote from the roadmap. They say, ResponseLoop.py is now an 8-domain mega manager. They know that one single file has just grown way too big and is trying to do too many jobs at once, and that's just not a good way to build software for the long run. So the number one priority is to fix it. They're breaking that one monster file into 3 specialized modules. One will be in charge of getting the context ready for the AI. Another will handle that 2-pass memory check we talked about. And the original file will be slimmed way down to just manage the main conversation. It's just classic, solid software engineering. And once that cleanup is done, the vision for the future gets really exciting. Phase 2 is about giving the AI a better way to search its own long-term memory. Phase 3 aims to teach it how to break down a huge, complex request into smaller, doable steps. And then Phase 4 is all about making the user experience better and adding even more cool capabilities.
So what's the core philosophy holding all of this together? Every single decision here, from the memory design to those security layers, is guided by a really clear and smart set of principles.
Let's just run through them real quick. STEDLib first means it's lightweight, no heavy, complicated add-ons. Sandbox boundary, that is the non-negotiable security rule. Evidence bag is a supplement reinforces that whole smart memory design. Small model steering, we saw that earlier. It's all about using small, fast models for the simple stuff. And finally, reversible storage, which means data is never truly deleted, so nothing important gets lost by accident.
And this all brings us to a final big picture question. Mindshard Agent is all about being lightweight, self-contained, and secure by design. The whole system is built on these ideas of safety and transparency. So as we look at this blueprint, you have to ask, is this the model for how we should be building private AI tools, the kind of tools we can actually trust to run on our own machines? It is definitely a compelling vision for the future.